so yesterday we did that long division problem that was on that chart. On that chart that's on page 229. So it's right up here. Page 229. We went through this whole problem. That's right here. Right there. We went through that whole problem. Talked about how to do it and what to do, and you're going to have some more practice on long division tonight for homework. Okay? So you're going to get some of these. We're going to do some of them more in practice today in class, and then you're going to have some to practice at night for homework. But if you remember, we went through that. The question that I really want to get to is it says, is 2x plus 3 a factor of 8x to the third minus 12x minus 7? Is it a factor? And if I go back up here and I look, how come I know this is not a factor? Because it has a remainder, it means it doesn't go into it what? Perfectly. Evenly, I don't like the way it's saying that because that sounds like it goes into it 2, 4, 6, 8, 10, like that's evenly. I get like evenly when we say that we mean everybody gets the same amount. But I don't really like that, so I'd rather you say it goes into it perfectly. So that just means that there's no remainder. And since we have a remainder here, we know that this is not a factor of that. And the reason why is because it has a remainder left over. Follow me? All right. For these guys, there's a reason I don't like this one. I guess in the A, they're trying to help you out. But why don't I like A? What did they already include for you? That's not going to be there on the test, nor anywhere else on the EOCs or anything. Yes. No, they're actually asking you to do the division. They set it up as a division problem. Do you see the 0 right there? That's not going to be normally given to you. It's normally going to say 4x to the third plus 7x. And remember, you have to make sure you walk it down from 3, 2, 1. Now, you don't have to have that 0 back there. You with me? You can just, that'll be, if there's something left over, that's the remainder. Yes. No, you can put a plus 0. It doesn't. If I add 0, well, but think, like, no, seriously, if you add 0 or you subtract 0, is there a difference? So, it doesn't matter which one you put there. Now look at this one. Why is this one a little different? 4, 2, 1. What did they skip over? So what do we have to make sure we put in this one? A 0. All right? So let's go through and do, let's do this one together, and then I'll have you do these for homework tonight. All right, so here we go. How do I make x become 4x to the third? Thank you, Sierra. 4x squared. And 4x times x becomes 4x to the third. Anything left over? Now, this one's kind of tricky because this one actually just doesn't really matter. The 0 doesn't really hurt us not having it there. Because if you look, I can bring it down. Do I need to make anything this right here? Okay, what times x gets me to that? 0. Do I need to put a 0 up there? Does everybody understand that? So I can kind of skip over this one. How do I make x become 7x? Oh, not x. Remember, I work on those basic skills. 6x times x, well, is different than 6x plus x. 6x plus x is 7x. But we're not adding when we do this, are we? When I go from here to here, am I adding them? What am I doing? And 6x times x would be a 6x squared. Do you get what I'm saying? When I'm multiplying, I need what times x gets me to 7x. Just a 7. Because 7 times 1 is 7, and x times no x back there is just x. So there's my answer. Let's try C. 2x minus 3 goes into 4x to the 4th plus, what should I put in here? 0x to the 3rd plus 5x squared minus 7x plus 9. Yes? Okay. I'd appreciate it if I had some more talking back. How do I make, or what do I need to make become what? No. One thing you brought in, but leave it off. I need a 2x become a 4x to the 4th. All I worry about is this front number becoming this for right now. And then whenever I do that, I just have to multiply it by the 3, and just whatever happens, happens. Do you get what I said? How does 2 become 4? You with me? How does x become x to the 4th? X to the 3rd. Remember, Adam. Now, here's where I get to make my check. 2 times 2 is 4. X to the 3rd times x is x to the 4th. That's exactly what should happen. Now, do you remember the trick I told you? Instead of subtracting, what did I tell you that you could do? Okay, so remember that for later on. I'm going to put this subtraction sign here now, but I'm going to cross it off in just a minute, and we're going to add the negatives. Am I done with this 2x to the 3rd right now? What do I have to do with it also? Multiply it by the negative 3. Is there anyone else in this class who understands this process? Use your mouth, please. 2 times negative 3 is a negative 6, and x to the 3rd, do you see how that matches up with this right here? That's in line with this right here. These guys are in line together. Now, what did I tell you to do? What would I do? Add. And then what does that change this? Someone else besides Sierra, what does that change this 4x to? Negative, thank you. And what does that change this negative 6x to? That way I don't make mistakes on my signs. Because I'll guarantee you, right here, you had a subtracting a negative. And I almost guarantee at least half of you would have thought that that got you a negative 6x to the 3rd. Because you would have seen the negative here, you would have seen 0, and you would have just put a negative 6x to the 3rd. And that would be wrong. Are you following me on why I'm being so cautious with this? So please, change this to addition and change each one of these signs. And then, now I can just look. A 4x to the 4th and a negative 4x, what do they do to each other? What happens when I have 0x to the 3rd and I add 6x to the 3rds? And then, plus 5x squared minus 7x plus 9. I just write everything else down. You with me? Now, what's my new number I need to get rid of? This is my new number, and I need to make what become it? Only the 2x again. Do I worry about the 3 right now? No. 2 times what gets me to 6? Positive 3. X times what gets me to x to the 3rd? 2 times 3 is 6. X times x to the 2nd is x to the 3rd. Perfect. That's working out so far for me. Now, 3 times a negative 3 is a what? Negative 9x squared. Now, I'm going to write the subtraction sign in here. I'm going to go, you know what? I need to make this addition of the opposite. So I changed both those signs. How are we doing? Doing okay? This does what to each other? Cancels out. When I combine these together, I get 14x squared minus 7x plus 9. Now, what's my new number I need to get rid of? How do I make, and what am I trying to make become 14x? 14x squared, sorry. So, what do I need to multiply it by to get to that? A positive. Be careful, make sure you're thinking about positive and negatives. A positive 7x. Notice, if this would have been a negative, I would have put a subtraction sign right here where this plus sign is. You following me? So, 2 times 7 is 14x squared. 7 times that is going to be a negative 21x. Add the opposite. There's where I need to be careful. This cancels out, correct? Like it should. But what do I end up with right here? A negative 7x and a what? A negative 7x and a positive 21x. Do those actually really add together to get you more stuff, or do they cancel each other out? Why do I think they cancel each other out? No, not because they're factors. We're adding. We're not multiplying or dividing. They're opposite signs. What do positive do to negatives? They cancel out. It's like a wash. You ever heard someone call that? You're like, that's a wash. That's because every time you have a positive and you have a negative, they cancel each other out. How many negatives do I have? 7. How many positive do I have? So when I wash them all, like I say, okay, I got 7 over here and I got 21 over here. When I cancel all those out, what's the most I can cancel out? 7, right? Because this one's got, that's all it's got to cancel out is 7. My leftovers are going to be what? Positive or negative? Because I have more positives. This is the way that you actually combine my terms, and I'm telling you, we need practice on this. So what you really do is when you have different signs, the way that I do this in my head is I actually subtract the two numbers. I never subtract. I always add the opposite. I always add numbers together. The reason being is I look at their sign, and their signs help me out. If something is a positive and something is a negative, I know that I actually take the 7 and I minus the 21. If they're the same signs, if they're both negative, I actually add the two numbers together and then keep it as a negative. I'll show you what I mean in just a second. But do you see how this is a negative 7 and this is a positive 21? So I'm going to actually subtract those two numbers, even though I know it says a plus over here. I don't worry about that because I always make this a plus sign, and then I let the signs tell me whether I add or subtract. Does that kind of make sense? So then I subtract. When I subtract, 21 minus 7 is what? And my leftovers are what? Positive or negative? Positive. Now my new number is 14. Actually, same one. But that's okay. I got to do another set. I need to make this 14x. I need to make 2x become that. What do I need? And when I multiply that, I get 2 x. This is going to become a 14x. And 7 times that becomes a negative 21. Remember, what did I tell you to do? Do we subtract here? What do? Add the... Now watch how that helps us out. I'll guarantee you, if you went on your own, some of you probably did this and you subtracted these two numbers right here. But if you look, when I add the opposite, what's this 21 going to change to? And my leftover is going to be a 30. Yes? And remember how I wrote that as, you can write it as 30 over 2x minus 3. Are you following me? Now, is this a factor? No, it is not. How do I know it's not a factor? Because we got a remainder. What's this one up here? Is x a factor of these guys? Yes, because I had a 0 remainder. How are we doing? By the way, here's what I mean. If I have -7 plus, minus 10, here's what I do. I think, actually, -7 what? What did I tell you I always do? Add the opposite. Now is when I think, are they same signs or different signs as to whether I add or subtract? Are these guys same signs or different signs? If you have negative and you add more negative, what are you going to get? More negative. That's why this becomes more negative, which actually is a smaller number. I understand it. I understand it's a smaller number. That's because I got more negatives. You following me on this? That's how I always do same signs, different signs. I always add. If I had even as simple as problem as this. The way that I think in my head, because I know this is not, I know it's 3, but to help practice when I was, trying this out, I would go 5 plus a -2. Change everything to addition. And then you can think same signs or different signs. Or, once you get older, or better at this, you're going to be able to go like this. What's the sign of this one? What's the sign of this one? So they're going to what to each other? Cancel out. The sign that's in front of it is really the sign that it is. You with me? If I had this right here, what's the signs? They're both negative. So what are these two numbers going to actually do to each other? So actually my answer is going to be a what? -7. The reason I'm going over this is I've seen a lot of mistakes on these kind of simple problems. So that's how I do this in my head. The sign rules will always work. It won't fail you. All right, last thing for this guy that I want to go over. We just said that this is division, right? What's the opposite of division? Shouldn't I be able to check my answer like 10 divided by 5 is what? 10 divided by 5 is 2. How can you check that? 2 times 5 is 10. Didn't I just do a division problem? Shouldn't there be a way I can check my answer? Now here's the tricky part. There's only one tricky part. One tricky part. If I take 2x minus 3, I have to times that by all of this up here, the thing that I just found, my answer. Are you with me? Now, there is this 30, but notice I'm kind of holding off on it. So before we get to this question right here, let me ask you a quick question. If I said 10 divided by 3, what does it equal? 3 with remainder 1. You following me? Okay. If I wanted to check that, would I add this one in first? At the end, Notice what he said is what he's trying to say is you would go like this. 3, what would you do first to check it? Times 3, which is what? 9. You would do that first. Then you would add that remainder that was left over. Are you following me? Well, let's tie that to this bigger, more complex. Idea is still the same though. What do? You multiply this times this. And at the end, after you've multiplied and distributed everything out, what do you have back here? That plus 30 is noticed back here. When you distribute, you will multiply this times this, this times this, this times this, this times this. Notice, how many things does this thing multiply to? 4. Does it multiply to the 30 that's outside? No. Then, before I would still have to combine like terms and move stuff around. I would still have to do this times this, this times this, this times this, this times this. Once I distribute both of those guys, then I combine all my x to the fourths, I combine all my x to the thirds, x to the seconds, blah, blah, blah. And then at the end, if there's a constant, I would add 30 to it, meaning just a whole number, you would add 30 to it at the end. That kind of makes sense. Why don't we do that for homework? I want you to check that answer. Put a little star and put check that answer because we really need practice on this skill. All right. Try this one for homework. I'm going to do this one. How are you going to do that? How are you going to determine if this is a factor of this? Divide it, and if there's no remainder, then it's a factor. You following me? Okay. Make sure you know the wordage. Make sure, because that's the verbiage on this is really tripping us up on the test. We're like, well, I don't know what to do. That's because you don't know your words. In order for something to be a factor, that means it has to go into it perfectly. Well, if it's going to go into it perfectly, then all I have to do is take this and divide it into that and see if there's a remainder. Following me? Now this one right here, do you see this when they give you a graph? You can't do the factoring thing, or you can't do the dividing by. Do you know what the equation for this graph is? No. So watch the trick on this one. Here's what we do. If this is a factor, doesn't that mean that 2x plus 1 would be one of my bubbles? Doesn't it mean that it also contains one of my zeros? Do you remember this from last chapter? Factors are going to find your x-intercepts. How do I find my x-intercept? It's when this bubble is equal to what? 0. So what do? Is I go, when does 2x plus 1, when do you equal 0? Minus 1, minus 1. 2x equals a negative 1. Divide by 2, divide by 2. X equals a negative 1/2. What does that mean should happen on my graph? The negative 1/2, comma 0 should be one of my ordered pairs over there, correct? It's negative 1/2, 0, one of your x-intercepts. Is that the x-intercept there? It's not. That intercept is negative 2, 0. Is that what we found to be true here? So is this a factor then? No, it's not. You were able to use your graph to tell whether it's a factor. Because if it's a factor, that means it contains my 0. You following me along on that? All right. How do we find out what x is? How can we find out what x is? This has to do with, remember our check that we just did? If I take some number, look at A, if I take some number and divide it by 7, and it equals 18 with remainder 2, how can I work backwards to figure out what that number was? Multiply 18 by, and then at the end do what? Are you following me? Okay? What can I do right here? Let's try B for homework. Told you you're going to have a lot more because we need to try some stuff. We're not translating well to the test, so I'm going to change stuff up. Right here, the same process is going to happen, huh? If I want to know what P of X is, what do? I multiply this times this, which means I'm going to have to distribute some stuff out. And then what do I have to do at the end? Add 3. Are you following me? So I'll even write this one down. It should look like this. Times 3x squared plus 14x plus 15. And at the end, what should I have? A plus 3. And you should FOIL all that junk out. Do we understand this? All right, let's roll to this next part. There's another way we can do this stuff. It's called synthetic division. All right, synthetic is a shortcut method for dividing polynomials by, now be careful, this is very important. It has to be by the linear factor of this form. This method requires fewer calculations and less writing by representing the polynomial and linear factor as a set of numerical values. So I'm going to go through what we do to do this process. Here's how we go this. Here's how we go through this. All right, let's go to this right here. This one is very, very important that you make sure you walk your polynomial down. That's still that same process is going to be. See how it goes from 2 to 1 to nothing? Then we're good in this one. We don't have to put any placeholder zeros. Are you following me? It's very important with synthetic that you walk it down. You've got to have that idea in your brain. So here's what happens. Do you see this right here? What is the root of that problem? How did you get that, Zach? Because if he plugs the 3 into x, what happens when you say 3 minus 3? What do you get? That's our factor. Okay? So this is R stands for our root. Does everybody understand where I got the 3 from? You're going to see a whole bunch of numbers. You got to know where the numbers come from. That 3 right there actually goes to right here in our synthetic. This is the process of synthetic division. The root went right here. That's my root. Does everybody get that? Now, do you see this number right here? What is it? 2? What is this number? And what is this number? And actually, this is a negative 3, and this is a negative 9. Are you following me? What do you see right here? What do you see right here? What do you see right here? Aren't those the numbers from right there? All you do for synthetic division is you write the root out here. You then write what are called the coefficients of what you are dividing into. Just the coefficients. Does everybody at least see where the numbers are coming from? And all you do is you go first number, you always bring straight down. So that's why this 2 came here. You then say 2 times 3. 2 times 3 is what? Do you see this 6 right here? 3, and you add these. Add these together. Negative 3 plus 6 is a, that's where that 3 came from. Then what do you think you do with this 3? Multiply it by 3, and 3 times 3 is? And watch what happens. Negative 9 plus 9 is what? What do you think this is? That's your remainder. Now watch what happens. Do you see that this really, when I put it back in my bubble, it's x minus 3. Because that's the root. Right? It's right here. It's what I was dividing by. You follow me? This down here is always going to start with x being 1 minus that. And these are the coefficients for all the next things that come after it. So my bubble right here, what was x to the power of here? 2. So what's this x going to be to the power of? Because it's always 1 less than what you had in the beginning. So it's going to be 2x minus 3. That is called synthetic division. Plus 3. Make sense? Let's try another one. Looks like they did these for you. All right. You see that this is the constant. So if I wanted to, I want you to actually think of what this problem actually said. If you can do this, you really understand this problem. Do you understand that this was actually, I'm going to start at the end, 6 minus 3x minus 4x squared. What am I skipping? Yeah, but so this is x to the 0. You follow me? Because that's the constant, so there's no x back there. You notice what I'm talking about? Because x to the 0 is just 1. I know, we're starting to get in some real math here. Are you seeing stuff that's not there? That x to the 0? Are you guys with me yet? This right here is x to the 0. This would be x to the first. This would be x to the, this would be x to the, and this would be x to the. So you see, my original problem said something like, it said this. 6 minus 3x minus 4x squared, and then x to the 4th. Yes? And they wanted this to be divided by what? X minus 2. How did she know that? Because if 2's the root, that means that when I plug 2 in, it should make that bubble 0. Now, what if they had a negative 2 out there? Then this would have been x plus 2. Are you following me? You seeing where the numbers come from? And then if you notice, all they do, when we do this synthetic division, no. Every day this thing does something to me. Yes, it does something to me. I don't do it to it. Bring that 1 down. 1 times 2 is, that's where this 2 comes from. Add these together. 0 plus 2 is 2. 2 times 2 is 4. I know y'all saw me close that out. This thing is possessed. Times 2 is 4. 4, remember, I'm adding. A negative 4 and a positive 4 become 0. 0 times 2 is 0. Add these together. Negative 3. 3 times 2 is a negative 6. Now, what do you know about this guy? Come on, tell me something like, Mr. Martin, I've been with you. This happened, so I know it's a factor. That means it goes into it perfectly. Are you with me? What would I multiply this by to get to that? Look right here. Let's look right here. How many times does this go into that? What did I tell you this becomes? 1 less than the highest power. Are you with me? What was my highest power? So it's going to be x to the plus 2x to the second, no x's, minus 3. And what I'm telling you is, if you took this right here, and you multiplied this by x minus 2, it would get you to this. Yes? Aha moments? Yes. Alright, so to start you out, if they ask you to do this, right here, what does that really mean? Divide. That's just a different way of writing division, right? They're just taking and they're saying, take this and divide it into this. So really, I could write that question like this. That's what I could write it as. You follow me? What's my root going to be? -1 is my root. This is the way I do this, by the way. This is the way we did it. There's -1, and I put this little box like to show you this is the root. And then I go, okay, what's my first thing? What's the coefficient of x to the third? If there's nothing there, what is it? No, it's a 1. There's an imaginary 1 there. Now, I have to walk this all the way down, right? X to the third. What do I need to go to next? Are there any x's to the second? So what do I put there? Are there any x's? So what do I put there? And then what do I put at the end? You see this is 3, 2, 1, 0. I make sure I walk all the way down. Drop this thing straight down. 1. Yes? 1 times -1 is -1. Add those together and you get -1. -1 times 1. -1 is a positive 1. 1 times 1 is a 1. 1 times a -1 is a -1. And -1 and 1 makes 0. Is this a factor? Does it go into it perfectly?
Yes.
And my answer would be x. I mean, if the question is how many times it goes into it, your answer is this right here. So what would my answer be? X to the second minus x plus 1. Follow me? Now be careful. I want you to do B and C. Oh, come on, give me one more better than that. Okay, this one is really important. This one right here. You see this guy right here? What's the problem with that? I can still do my synthetic. But remember, if this, we've talked about this, if that's my factor, how do I find my root, which is what I need to go right here? I have to say, how does this become 0? So how do I figure that out? I just make it equal to 0. Are you following me? And I just add 3, 2x equals 3, divide by 2, x equals 3/2. That's where they got that 3/2 from. Now, I do my synthetic division like I did before. Do you see how it goes 2, -6, 4, 2. All right there. Everything stays the same. The only tricky part about this one is finding the what? The root. And how do you know how to find the root? Whatever you're dividing by, whatever makes it 0 is going to be the root of it. That's the stuff, that's why chapter 2, chapter 3 leads up to chapter 4. So, I want you to try 5. That means you're going to take this right here and divide it by this. And what should your answer be? If this times this equals that, are you following me? Then this divided by this should equal that. So how you're going to verify this is you're going to take this right here, and you're going to use synthetic division, And when you get your answer of synthetic, it should be that. You following me? All right.